Hello, everybody, and thank you for joining us today. My name is Damian Diaz. I am the Director of Marketing here at IO Integration, and today we're going to talk about the evolution of DAM and how, with the introduction of the semantic and graph database, that has kind of changed the way we perceive this technology. Today we're going to have two presenters. We have Rich Carroll, who is a Solution Sales Manager here at IO Integration, who will be walking through the history of the technology, and Wendy Weers of Senshare, who is a Business Development Product Manager, who will actually show us a real-world application of how this technology works. So with that being said, I would love to hand this over to Rich Carroll, but first of all, just a quick minute of housekeeping. Everybody is on mute, but if you have any questions, there's a questions panel in your GoToWebinar panel there, and you can ask all questions there, and we will address them at the end of the presentation. And with that being said, I will pass this over to Rich.
Thanks, Damien. Can you hear me okay?
Yes, I can.
And you can see my screen?
Yes, I can.
Fantastic. Okay, so again, my name is Rich Carroll. I'm on the IOI team. Thank you, everybody, for making time for us today. I think initially when we were asked to speak on this, I was a little daunted, thought that maybe I'd drawn the short straw on trying to describe semantic databases, but actually it's quite a privilege. It's an interesting topic. There's been a lot of development in this area in the last several years. There's plenty of reading material out there on the web if you want to look and see, find out more information about semantic and graph databases. I have a couple of slides I'm going to run through, really talking about kind of the evolution of DAM and kind of how we've progressed to where we are today. So I'm going to give you a little timeline, talk about how things started, and then talk a little bit about the abstraction and the power of nil, how we deal with assets and DAMs that aren't really assets in the traditional sense. As well as I'm also going to talk about correlation, or how we translate kind of traditional linear databases into something that more closely resembles the human mind. And then I'm kind of wrap it all up and show how complex today's challenge is. So initially, DAM really was basically file sharing. It was a local area network. There really wasn't a database behind it. It's still being used in many ways today. If you think of like FTP sites, these are just simple folder structures with no metadata attached that people could go find what they're looking for, hopefully, and pull down the asset. That then progressed in the early 90s with some simple relations between the assets and their metadata. This started to allow people to search or to look for other information besides just file names for those assets. The problem was these are still very siloed structures and very limited in how they could share that information across multiple environments. Mid-90s obviously brought out a pretty big evolution in how we communicate. We really began to see this hyper sharing of information as the webs first started to take hold, and that really helped fuel the evolution of DAM, because those assets were being used across not only the websites themselves, but in the construction of those websites and in information in PIM systems and elsewhere. Over time, though, those web-based solutions grew really exponentially. We had, certainly by the mid-2000s, the social explosion. Instead of a couple of images that we were trying to manage, we have millions of people sharing cat pictures, right? So we had a different sort of challenge, and DAM needed to adapt to that. I think what we saw in the last several years was more and more focus on big data and cloud and software as a solution approaches, but that really is a recognition of the underlying issue, which is that growth of assets, that sheer what was a dribble in a small river became a flood of lots of assets that need to be managed and searched and found. And that kind of brings us today with a newer approach, a different way to look at the core problem, and that's using semantic and graph databases. So let me just step back a little bit. Let's talk a little bit about what is an asset. Most people traditionally think of assets as files, right? JPEGs, movie files, Excel spreadsheets, stuff like that. Most DAMs house lots of those different file types and then track all of that information in a database. Before semantic and graph databases, we had hierarchical and relational databases. And a little piece of trivia, both hierarchical was invented in the 1960s, and relational was built up in the 1970s, both at IBM. To give you some perspective on how old those databases are. But they basically have a very simple association between the asset and the piece of metadata. So what you have is the file name equals logo.jpg, the file type equals JPEG, the date created equals October 10th, 2016. Up until now, that's really been the extent of our vocabulary. It was always this equals that, this equals that, this equals that. And the way that that's physically built in a relational or a hierarchical database is you have all of this information in what we call key pairs. You can kind of think of it as like an Excel file with 2 columns. File name equals modified, or file name equals X, modified date equals X, etc. You build up a lot of these individual tables, and you start to build out a traditional DAM. So the problem becomes when these tables grow, it becomes computationally expensive to do deep searches or look across very large data sets. So in this example, I'm actually showing you just one of the tables. Most DAMs literally have generally anywhere from dozens to 100 different tables. But in this case, I'm just looking at the file table. So if I wanted to do a deep search and maybe say, well, show me when this file was approved, I would first have to go to the file table, look up, get its file ID, and then I'd have to look at the larger table map. So this is a abbreviated view of a large table map, and file ID is a little hard to see. It's right there in the middle of that schema. But if I wanted to see who approved it, I'd then have to go to the approval table and do another lookup. And when I do a lookup to see when it was approved, I'd have to also do another lookup in the user table to see who approved it. So to do a simple search, I basically would have to do what's known as a join across multiple tables and get the results back. Now, normally you might not think that takes that long to do, and you're right, it might only take milliseconds. The problem is when that file table has millions of records in it, or the user table has hundreds of records in it, or the approval table has thousands of records in it. Doing that query across those multiple tables takes a lot of time. And most users today are accustomed to near instantaneous feedback. So if you have to do a search across really large data sets, and it might take 5 seconds to get an answer back, people assume that something's broken in the back end, when in reality it's just the limitations of what the database is allowed to do. If you also think of industries outside of marketing or advertising, like legal or healthcare, they have very large text-heavy data sets, or education. There's also large collections in museums and zoos, or supply chain management. In the retail side, you have these very large PIMs, each of which has metadata that we might want to pull into a digital asset management system. But right now, it's a very difficult and expensive, computationally expensive thing to do, because we have this very large landscape, but we're still only using this very simple association, the equals. This equals that, this equals that. So let's talk a little bit about DAM, or digital file management as we know it. Up until now, when we were talking about assets, we've really only been dealing with a file or files. So the question is, can an asset be more than a file? Can it be something concrete? Can it be something more abstract? As an analogy, we could talk a little bit about the concept of zero in mathematics, right? It took centuries to emerge, but really that zero was a huge breakthrough, because it allowed for the theoretical. It allowed for the conceptual, the notional, the intellectual, metaphysical, ideal, academic view of that information, rather than cold, hard 1, 2, 3. A zero by itself is nothing, but without a zero, you cannot count anything. Therefore, a zero is something yet zero, right? Really deep. On the surface, it seems fairly simple to us now, but when this concept came out, it was revolutionary and really changed how people thought about mathematics. Abstraction, much like zero, means that you can represent something that does not yet exist, or might have a real existence at some future stage. So another example might be, let's talk about it like a basket, right? That basket is an asset by itself, but it's also a container. So this same empty basket or asset can hold something in the future that can also become an asset or assets, right? Because we fill that basket, now we have many assets. So what we've learned is that assets do not have to have something concrete associated with it. That empty basket itself can become many assets. An asset can be anything you can think of, or nothing at all, right? And any kind of asset type, even an abstract asset. So it doesn't have to be just files or creators of those files, but it can be thoughts or ideas or intents or strategy. That asset can be anything or it can be nothing at all. And that's really what we mean when we talk about abstraction. The core benefits of this really are that it allows us to have more than just a file or no file at all or thousands of files. Or it can have things that aren't files, like a timeline that's being used in resource planning, or employees that are being used in resource management, or maybe a look board, or some conceptual ideas that are being used for strategic purposes, right? All of those can be abstract assets that can be managed in a semantic dam. So the next thing I want to talk about briefly, though, is correlation and being able to distinguish relationships. As I said before, traditional dams use just that equals construct. That's really all they have. This equals that, this equals that, this equals that. The problem is that doesn't really always show us the weight or the importance of that information. So correlating the information is important as well. So let me give you a quick little example here. We have Mary, we have John. John loves Mary. Mary and John race together for Team Nissan. John actually also works on the crew for Mary's car. Mary actually liked the car on liked a Facebook page of the car. All of those are different pieces of information that we would like to be able to manage about John and Mary. And the problem is traditional databases give us very limited power to deal with that. Traditional databases have those all equal. That John loves Mary, or that John went to school with Mary, or that John races with Mary. All of those have the same sort of weight. The problem is when we get beyond the very simple relationships, and let's say that Mary maybe authors a blog that posts on Facebook and gets a whole bunch of likes from a bunch of different people. And by the way, that blog, she also translated it into Japanese because it was about a Japanese police car. And now we actually know that Mary speaks Japanese, as well as the fact that not only are they involved in this team racing, but they do all of these events, and there's concept cars. Correlate all of these different pieces. Really difficult to do in traditional databases. So, oops, I got a problem with one of my builds. Let me click one more time here. In a graph database, we still take all of the same information, all of the metadata, the file ID and its name and its file type and creator, and we still apply all of that information to the asset. However, we also have an additional level. We have the relation between this asset and other assets, and that relation can also have metadata attached to it. So we can say that not only does John love Mary, but that John races with Mary, and John went to the same college as Mary, and we can assign different values to each of those relationships. And this starts to get really powerful as you expand across not just a simple relationship between John and Mary, but hundreds of relationships, hundreds of assets, all of the different metadata that goes along with that, and the weight of all of those relationships as well, right? Because normally when we ask somebody to kind of map out for us what they think their metadata needs to look like, this is generally kind of what they draw. They draw a graph database representation. The physical model is the database model in a graph database. Another way to look at how information is stored in a graph database is what we call a triple. And this is the three pieces of information. You can think of it also as like a subject, predicate, object. And it lets us tell a story. John loves Mary. Mary occasionally drives the Mazda, and John loves his Mazda, right? Three different relationships, each of which has different weight. John loving Mary and John loving the Mazda clearly mean different things, at least for Mary's sake, I hope so. But traditional databases express John's feelings towards the Mazda as having the same weight and the same value as his relationship about Mary. A semantic database allows us to describe different weight, different meaning, and really understand the correlation of how those different pieces of information are important to each other. So today's world is this huge network of huge quantities of lots of assets that are all interrelated. I don't know anybody who would say that that complexity is going to get easier, or that the total number of assets and uses for those assets is going to decrease. And the problem is, it's really difficult for the human mind to navigate alone. There's just the sheer size of the data sets are too large for us to understand on our own. We need a better nuanced understanding, and we need better tools that are capable of extracting meaningful content, meaningful information from this network. And the only way that we see to actually solve this problem is with semantic databases. I really think of the holy trinity of the digital area as being assets, metadata, and their context to each other. And we need to have a nuanced understanding of how they operate in order to be able to deal with very large data sets. Oh, I apologize. I missed a build. Metadata and taxonomies only describe one aspect of an asset. Assets are more complex than just files. Assets are like human beings in that they have lots of different facets. And metadata can be more than this equals that, this equals that, this equals that. The association between the asset and the metadata itself has value, right? We know that the asset has value. We know the metadata has value. That relationship, though, between the asset and its metadata has value. And relational and hierarchical databases are limited in their ability to extract that information about those assets without spending an awful lot of time searching very large data sets. As we start to look beyond just what we consider traditional DAM and include CRM and PIM and MRM and ERP, being able to pull all of those things together into a single interface really is a true digital asset management solution. This massive ocean of assets and metadata really threatens to be nothing without a semantic understanding of how they correlate and interoperate. Thank you. That's the end of my slides. What I'd like to do now, we can either take, Damien, we're going to take questions at the end, correct? After Wendy's had a moment.
Yeah, we'll take questions after we take a look at what Wendy has to present.
Okay.
Thank you, Rich. Now, if someone can just make me presenter, then I can show you how this would really look inside a system. All right, well, hopefully you can all see my screens.
Yes, we can.
Yes.
Great. I've got a little bit of feedback from you, Rich, so if you could put yourself on mute, that would be awesome.
10-4.
Thank you. Right, well, thank you everyone for your time today. Rich has some interesting points about how to store your content, your assets, how to make abstract assets, how to make the connections and build context in your assets. So what I'd like to show you now is an example of the SendShare tool. I'm going to log in here as a webinar user and show you how those can be represented, how those relationships can be represented, and have a look at where Rich came from with his history and looking at the different kind of types of ways you can store content. So I'm going to go here to my task list. I have some different types of assets. And as Rich said, these can be abstract, they can be pictures, they can be whatever you want. So what I'm doing here is, I'm just going to move that way now. This is a relational asset. So this is kind of the example of an image on your desktop, on your folder structure, wherever that may be. If I select this image, you can see it has no relations. So this image, to all intents and purposes, is just floating around somewhere. We don't know what it's related to. We don't know what the context of this asset is. And all we have is the metadata and the actual file. So if we were to have to change this image, let's say, for example, we had a copyright issue, or we had a change required for that image, we would have no idea where this image was used because of that lack of relationships. Let's have a look at another way that you can perhaps store systems in maybe more other perhaps DAM systems. Here we're just using kind of a folder structure. So this is a hierarchical asset. It's an abstract asset, it's just a group, but you can see that it only has kind of one-way relationships. So this folder has these folders underneath, and then if I click through, that folder has this content. So again, it's a very kind of one-way direction relationship between assets. But again, that doesn't really show me context. All it shows me is that this particular image asset is in that particular folder, and that folder is in another folder, and so on. So again, no correlation, no information about this asset except for where it lives, what metadata it has, and what the file looks like. So let's now have a look at how an asset could be represented using a graph database on the back end of your DAM. So here we have this user graph. Now this is my representation of Rich's John. Now we can see here that this user, this person, has got relationships to other types of assets. So if I just scroll out a little bit, I'll zoom out rather, what I can see here is the context, the information about this particular asset or person. So I can see that he's following Mary, not spookily, I mean, on the internet. He's bought a Mazda. He loves Mary. He has a hobby, that's Mazda racing. He's been competing in some races. He's written some articles. He's liked certain things. And this now gives my particular user, this guy graph, all of the context that I can imagine. So if I want to have, let's say I want to say, who's racing, who likes Mazdas, who's bought Mazdas? I know that because there's an intrinsic relationship between that Mazda and that particular user. If I want to find more information out about Mary, I know that Mary loves this guy, and so on. So having all of these relationships between the different assets gives me this depth of information that I wouldn't have if I only had metadata and a file. So let's have a look at some of these other assets we have here. So let's have a look at this race of champions. Now, again, talking about abstract assets, this is not a picture, it's not a video, it's an event. And this event has certain tasks. It's located in a certain place, because we can see the location relationship. We can see who's competing. We can see what media we've got, what ideas we've got, what tasks we've got. So again, this event, single asset, does not live on its own. It's related to all the other pieces of information that are relevant for this particular asset. Let's go back. I want to go back to this graph guy. Let's have a look at the car he bought. I know he bought this MX-5, and I can click on that MX-5 and see how that is related to other assets as well. So I know that this particular car has won an award. It's got some articles written about it. It's been placed in certain outputs. It's liked by certain people. It's followed by certain people. It's bought by certain people, and so on. I couldn't capture that information through metadata. It would take me an awfully long time to set it up. It would take me an awfully long time to input all that information. The fact that these people like this car, the fact that these awards have been applied to this particular car asset. That kind of information cannot be achieved through metadata. It can only be achieved through these relationships, and to that end, through a graph database. So let me zoom this back up again, and I'm going to pop into my favorites here. Let's kind of take that out of the abstract now and look at a more real life example. Now, I'm sure you all have images knocking around your systems, your servers, your folder structures, your hard drives, and so on. This is kind of a classic example of why you need to have that context of that particular image in this case. If I click on this image asset here, it's just a JPEG. But let's say I do want to change the copyright, or I do want to pull this image, or I want to make some changes. I don't want to just make changes to that image without knowing what it's going to affect. And here with those relationships, I can see what other assets are going to be affected by my change. So I know maybe that it's been output into a print article. Maybe it's been output to an online channel, to a website. Maybe it's been output to social media. I need to know, I need to make that decision about what changes I'm going to make and how that's going to affect my different outputs, my other assets that are related. So that's just an example of an image. But as Rich was saying in his talk, you know, the concept of an asset doesn't just have to be file-based. So I'm just going to pop up here. Here I have an empty asset. It's an empty asset. It's got a name, just doesn't have a file yet. It's also got relationships to other types of assets. So already I've built in this kind of structure of the asset. I know who wrote it or who's going to write the article or going to take the photograph. I can maybe spin off tasks here, workflow tasks. I know it's been assigned to certain outputs. I'm going to output it on social media, perhaps. All of that information has already been generated. I've already created those relationships, that context, without even having a file. So when I do have a file, I can just open that asset up. Here I have, just to zoom up a little bit, lots of different information about the asset. I know the contract we're going to use. I know where it's going to be placed. There are different tasks here, different authors, different copyright information. And as soon as I'm ready, I can just take my picture and pop that into SendShare, filling that asset up with that particular file. Now, what we've also done here, if you notice, as I brought that image in, we've actually filled in more information, more metadata in this case. So all the IPTC information from that file is being brought in automatically for this particular image asset. But I created this asset before I even had the picture. I've created the relationships, I've created the workflows, I've created the tasks without actually having to have that particular image file there. So that's kind of the real benefits of having a true DAM with a graph database on the back end. It's this ability to build the context, to build the importance, the weight of where these assets have been used, what effects would happen if we change those assets, and how we create the relationships in between. And it's not possible to have that with any other back-end database, only with a graph database, but that allows you to have these pure contextual relationships between assets. So that's kind of my very quick part on how you can visualize, how you can create, and how you can utilize graph databases in the true sense rather than just through a presentation, perhaps. So I'll hand it back to you, Damien. Thank you.
Well, thank you, Wendy, and thank you, Rich. So we're going to take some questions now. So if anybody has any questions, please feel free to type them into the questions panel of your GoToWebinar control panel. The first question I have is in regards to these relationships. Are these relationships, how are they created? Are they manual or are they predetermined?
That's a good question. A lot of the relationships, and again, it depends on what kind of relationships you require. So the example that I used here with a car and an award and a similar and an assigned and all of those kind of different relationship types can be defined by the customer. Some of those can be created manually. So I will then say, you know what, I'm going to create a whole lot of images that are related to this Mazda MX-5 product. So that would be a manual creation of that link, that relationship. However, if I place this product perhaps on, I don't know, on a website or on a print sheet, that relationship would be automatically created. So the system is automatically knowing that it's going to be placed in XYZ. You don't have to make that manual connection yourself.
Okay, that's great. Great. Rich, you want to take the next question on?
Yeah, sure. And another question for you, Wendy. Traditional databases have problems when you need to remodel that information. Is that also an issue in a semantic database?
Right, good question again. It is not, because you have this kind of 360-degree view of data, if you like, that kind of flat hierarchy, that flat file scenario that you get on older DAMs is not the same inside the DAMs with the graph database. That data modeling is very, very easy to do. And I think, like you said earlier, you know, when people define their metadata, actually 9 times out of 10, they're defining a relationship map, if you like.
Okay, great. Do we have any other questions coming in from folks? We just wanted to make sure we get any other questions addressed that anybody has.
Damien, I see one here. The question is, can you have compound relationships where you can have the same two assets have multiple values associated to each other?
Absolutely, absolutely. One of the benefits of having relationships and metadata, that combination of the two, is the ability to actually have metadata on a relationship. So you could have relationships between multiple assets that have different values depending on that relationship.
Yeah, I know another good example of that, Wendy, is just social and being able to express that two assets are related in some social sphere, so that you could say it was liked on Facebook or tweeted about or hearted on Instagram or published on LinkedIn, but you can take each of those individual relationships and you can basically have a superset and say it has social value across any one of those relationship types. So it's easier to model. Traditionally when people look at the effectiveness of an asset in the online world, they have to culminate that data across each of those sites independently and then weight them and try and figure out how valuable it actually is. In a graph database, you can do that with a single search and get results across all of those different uses of the asset.
Absolutely, and that's an interesting point, actually. It's all very well finding assets, searching for and finding your different pieces of content, but finding them through that relationship is a very powerful part of systems, for example. So in this tool, SendShare, we can actually search on relationships. So maybe I want to find all images that are in a certain workflow state and are related to a certain campaign or are related to a certain group or what have you. So it's not only the ability to view and visualize those relationships, but also the ability to search through those relationships using a standard search engine like we have inside SendShare.
Okay, so we have another one here, and is it common for DAM platforms to use semantic or graph databases? Is that a common practice?
That's a good question. I'm kind of one-sided a little bit, but in my opinion, as far as I know, it is not a standard to have graph databases. It's a very moving technology, and SendShare as ourselves, we've built our own graph database because we couldn't find the tools and the technology to utilize ourselves, so we built our own solution for that. But no, I've not seen very many DAMs with graph databases on the back end.
We do know that some of the larger players in technology are using graph databases to manage their marketing automation, so that they are in use. But as a pure DAM, I believe SendShare is the only product that is using a graph database behind it.
So to kind of add on to that, we have another question that just came in that kind of ties into that. And should it be a standard practice to have a graph database moving forward?
I would like to say yes. I think the problem is if you're looking at, people understand hierarchical and relational databases. They've been around literally for decades. And so there's lots of skill out there in being able to manage those assets. And for most simple business cases, you can use traditional database models to solve those problems. The issue that we see is that over time, and actually at Henry Stewart, Teresa Wrigley was speaking about this. She did a session about the 3 to 5 year itch, where you have lots of customers who they may have purchased a solution that fit their particular department's needs initially, but 3 years down the road or 5 years down the road, the fundamental business challenge has changed. And it's very difficult to then remodel all of that information in the traditional databases and repurpose it for new business uses. And to be honest, I have no idea what's going to happen 3 years from now, 5 years from now, right? That's part of what I like about working in IT is it's constantly evolving. But the graph database allows us to look at that data differently in the future without having to restructure all of the data in the database.
And I think also, as we move further and further towards artificial intelligence and the way that the human brain works with different connections, I'm thinking about 10 different things at the same time, and those different thoughts have different associations with other things. That's how the human brain works. And we're moving more and more towards that artificial intelligence where I know that I've bought a car, I know that I've done this and I've done that, and representing that in a graph database, I think, is the way that we're going to go anyway. So any kind of future-proofed system should have the capabilities to create relationships between content.
Yep, agreed.
So that looks like all of the questions we have so far. So I just want everyone to know who's online here that we are recording this and we will be sending this to everyone who registered. So if you wanted to share this with your team or, just wanted to have a second look at it, we will be sending this as soon as we have this recording all ready to go. With that being said, I want to thank all of you for joining us. And please, if you have any questions, you can send them to Damien at IO Integration. That's DAMIAN at iointegration.com, and we'll be happy to get back to you with any questions you may have around this technology. So once again, thank you, and we look forward to talking with you in the future. Thanks, Wendy. Thanks, Rich.
Thanks very much,
everybody.
everyone.
Have a good day.